From deep-sea beds to the harsh terrains of the Middle East and around the world, there are industries that battle explosive threats every day. Their everyday job begins and ends with the word risk. The people who run these places play life and death games every minute, for success is hidden behind these dangers. Industries such as oil refineries, gas and petrochemical plants are taking extreme measures to safeguard their units. Due to the presence of hazardous materials, these industries are highly vulnerable at any given time. A small human error or a tiny electrical ignition could trigger a great calamity to the industries. Every year, industries like these come face to face with disasters, putting hundreds and thousands of lives in distress, at the same time delivering substantial threat to the environment. In order to combat these threats and challenges, organizations around the world spend a great amount of time and money to prevent any such disasters. Ultimately, their goal is security. Govan Industries Private Limited is a well-established Australian manufacturing company for over 6 decades, involved in explosion-protected electrical equipment. The company was established in 1949, and ever since, it has grown into one of the most reputed companies to provide standard and trusted electrical security equipment to many large-scale heavy-risk industries. It is also one of the few Australian companies supplying to both the domestic and international markets. Govan's quality has been a hallmark highly valued by its customers. Govan's innovation and business strategies have left a prominent mark in the world of electrical equipment manufacturing industry. After successful business establishment in the Western countries, Govan began to expand to other parts of the world. Unlike other manufacturers, Govan follows scrutinized and unique strategies to provide state-of-the-art explosion protection devices to its customers. Govan believes in delivering safety where it matters the most. The research and development team at Govan uses computer-aided drafting techniques to produce a full range of flame-proof (EXD), increased safety (EXE), dust ignition protection (EXTD), and pressurized (EXP) electrical equipment. Govan products are used by all major oil companies in Australia and are exported to over 20 countries in the Asia-Pacific, Middle East and Far East regions. Govan's Indian production facility at Chennai is a multi-phased manufacturing establishment. The output of this foundry varies from die-cast aluminum fittings to castings and fittings made out of fabricated first-grade stainless steel. Govan's state-of-the-art foundry is located at Chennai, India, where the whole process takes place. In the production of castings, various operations starting from sand preparation to final casting is carried out here. 2 types of casting methods are followed in the foundry: gravity die casting and sand casting. For sand casting, finely sieved river sand is mixed with Faseco-make bentonite powder in right proportions to give a proper mold. This mixture is then poured into the sand muller machine for mixing. After 20 minutes of mixing, the sand is collected from the muller machine and moved to the mold making area. 2 halves of relevant core box for the required pattern are prepared, and sand-selected mixture is poured into it and rammed for compaction. The next step is to make the mold. The required pattern is placed inside the molding box. The runner, riser, and gate are put in place to collect excess metal while pouring. Then again, the sand is filled into the core box and compacted with a pneumatic rammer. The runners and risers are removed. Proper gate cuttings are made to give way to the smooth flow of molten metal. Ample time is given to the mold to gain strength. The core box sections are separated and the master die is removed. Once the master die is removed, the boxes are joined together. Now we have a hollow impression of the master die on the sand mass inside the box. In the meantime, molten metal is prepared to create the mold, where the aluminum alloy ingots are melted in a temperature level between 700 and 760 degrees Celsius, depending upon the thickness of the desired casting. The molten metal is collected into a ladle and then poured into the prepared mold with precision through the gates. Ample time is allowed for solidification. When the solidification is complete, the mold boxes are removed and the solid casting is taken out. Another type of casting method employed in Govan's foundry is a gravity die casting. In this method, first, the high-grade steel metal die is preheated so that once the molten metal is solidified, the casting would not stick to the die. Molten metal is poured into the die and pressure is applied evenly from all sides to create a precise casting. Once the castings are cooled, they are moved into the cutting division. Then the castings are moved to the machine shop. The machine shop is equipped with advanced computer numeric controlled machines called CNC for drilling and milling. Two CNC machines, the VF3YT and VM-V60TC24 employed in this section, are capable of performing multiple functions like drilling, turning, milling, and tapping at the same time. The VF3YT is equipped with an auto tool changer with 24 tool holdings and a field rate of 1 to 12,000 millimeters per minute. The VM-V60TC24 is equipped with an auto tool changer with a 24 tool changer and a field rate of 1 to 10,000 millimeters per minute. These CNC machines work according to a computer program written as per the product specification. These automated machines accurately follow the instructions given by an onboard computer. Once the program begins, the machine automatically selects and changes the required tools to carry out a particular task. The whole process is done with great precision. Radial drilling in the CNC is used to perform hole drilling and threading operations on process parts. The drill bits used in this machine are made of extremely durable titanium alloy. Another important equipment in the machine shop is the automated lathe. It's a CNC machine with automated processes that are one of a kind. This is the thread cutting process used on the GL7 light fitting. Castings from the foundry are placed inside the lathe onto the chuck. This chuck is rotated so that with a fixed tool, the metal is machined from the part to create the desired threading. The movements of the tools inside the lathe are controlled by the onboard computer. Once the products receive their material movement tickets from the machine shop, they are moved to the testing division. The objective of the testing is to check the durability of the component in high pressure conditions. The pressure testing equipments are motorized and fabricated to use. These equipments are capable of testing up to 20 bars. In this process, the components are fixed on a test bench where a high-pressure water pipe is connected beneath the table and water is pumped into the inner volume of the components to check if they hold in high pressures. Then the technicians check the surface level for any bulges or distortions. Also, visual inspections are carried out for any leakages or cracks. Initially, in this process, castings are dipped in 7 tanks of Emkin chemical solutions to work specification. 2 types of pretreatment take place during powder coating. One is the ferrous pretreatment and the other is the non-ferrous pretreatment. The ferrous pretreatment is a 7-step process. In step 1, the castings will be degreased in alkaline-based chemicals in 65 to 75 degrees for 20 minutes. In step 2, the castings are rinsed in the ambient temperature. In step 3, derusting with acid-based chemicals in the ambient temperature for 10 minutes. In step 4, water rinsing is done in the ambient temperature. In step 5, surface conditioning in alkaline-based chemicals in the ambient temperature for 10 minutes. In step 6, phosphating under 70 to 80 degree temperature for 10 minutes. And in step 7, the castings are finally rinsed in hot water. Unlike ferrous pretreatment, the non-ferrous pretreatment process has only 4 steps: degreasing, water rinsing, chromating, and hot water rinsing. Castings are then dipped in clean water, rinsed and dried in open air. Later, these castings are hung in a conveyor and sent to the powder coating booth. In the powder coating booth, The materials are coated evenly with high-quality paint for a professional finish. After the coating, the materials are carried through the heating oven by the motorized conveyor. The conveyor maintains a steady speed of 0.03 to 0.5 meter per minute, while the oven temperature is maintained at 180 to 220 degrees to cure the paint. Finally, the components are out from the heating oven, where they will be visually checked for defects. All castings, MS sheets and enclosures are pre-treated and then powder coated with epoxy powder in desired color shades. In this section, the production team creates another type of flame protection electrical equipment made of SS or MS grade stainless steel sheets. It begins with obtaining raw stainless steel sheets from the stock. These sheets are moved into the sheet cutter, where raw sheets are sliced into desired dimensions. These sheets are then moved into hole punching machines, where precise duct vents and screw holes are made. After the hole punching is performed, the corners of the sheets are removed in a V shape. This is performed to ensure smooth and strong joints when the sheets are joined together. These sheets will then be moved to the bending section, where the desired bends and folds are made on the component sheets. These high-end machines are exclusively designed to provide accurate and measured bends. The components are visually examined for improper bends and out-of-place shears. Then, a series of drilling operations are performed on the plates to create box sections and covers. After bending, if any deformation is found, manual straightening is applied, followed by an initial welding to the corners to preserve the correct shape. After the checking process, a full welding is performed over the box edges to ensure tight sealing. The welding process is crucial as it determines the overall quality of the product. After welding, the excess weld material is grinded away. To double check the quality, another round of visual inspection for weld breakage is carried out. After this, the product will go to the buffing division. There are 3 levels of buffing carried out in this division: coarse buffing, nice buffing, and fine polishing. The first one is polishing with a 120 mesh emery wheel. The second step involves polishing on a 150 mesh wheel by applying buffing cake. After the buffing process, the components are ready for electro-polishing. In the electro-polishing division, the components are treated with K2 paste to remove black spots resulting from welding, and then the components are kept soaked in acid for 1 hour. After acidification, the components are degreased by soaking in a degreasing solution, which is prepared by mixing 3 parts of water and 1 part of degreasing agent. It takes 15 minutes to degrease. After degreasing, the components are rinsed with fresh water and taken to the electro-polishing tub filled with acid-based electro-polishing chemical. The electro-polishing tub is maintained at 40 to 55 degrees Celsius. After electroplating is done, the components are passivated in nitric acid, and finally they're rinsed with fresh water and dried in open air. Once they receive their final inspection, records are entered in the logs, and then the components are moved to the assembly and dispatch section. Here, individual components are assembled to produce final products. This section is also responsible for handling wiring, screwing, and sub-assembly of components. Glass fixing for lighting products is another activity performed in this section. Here, high-quality heat-proof glass is glued to the front cover of lighting equipment. Powerful silicone glue is used for this purpose. The assembly section ensures that all components and parts are up to the mark without any tolerance fallouts. Tested OK pieces are packed and set for final inspection. The final inspection is done under the direct supervision of the production manager. Fully tested OK quality products are arranged in stock and marked ready for dispatch. After cross-verification with client orders and other specifications, the pieces are marked with the product number, codes, and manufacturing dates. The dispatch boxes will then be assigned with a package number, quantity, and other details. Later, the boxes are moved to the cargo bay for final dispatch. As our world is witnessing new technological advancements every day, the need for security is highly demanding. Throughout our journey, we've been continuously improving our manufacturing methods to produce best explosion protection devices. For over 6 decades, Govan Industries has played a pivotal role in manufacturing sophisticated explosion-proof devices. We've been constantly sharpening our tools to produce explosion protection devices that would meet the critical demands to industries such as oil and gas, refineries, and petrochemical plants. Being a pioneer in manufacturing of explosion protection electrical equipment, Govan's unprecedented service and success is proven time and again. Today, Govan has grown to be a successful heritage that boasts in providing state-of-the-art products and services to its clients with well-defined quality business processes and global ambitions. Govan invites you to share the success of its global ambition as we march on the global path to making our vision a reality.